Hello everyone, on behalf of Group 5, I would like to introduce myself. My name is Nathanael Roberto and I'm from Material and Metallurgical Engineering 2020. First of all, I would like to introduce my colleagues Julian Baita and Yusuf Bayu. Today, I would like to take this opportunity to talk about the application of material chemistry. I'll start with material chemistry. So, what is material chemistry? As you might not know, material chemistry is a science of chemistry that studies organic and inorganic materials and the structure of chemical substance. Since the era of modern chemistry in the 19th century, chemists have been developing new materials and also processing materials that exist in the nature. Currently, we have entered the millennium era with high technology. Therefore, this technology can be used to discover and develop new materials so that can be used as a specific function. Materials can be classified based on their type and function. Based on their type, as you can see in the picture here, they are metal, polymer, ceramic, and composite. Meanwhile, based on its function, they are used as aesthetic, structure, and functions. On to the next topic. The first one is liquid crystal. Liquid crystal is a crystalline solid with condition where the particle arrangement remains regular when they begin to melt and change into water. In recent years, liquid crystals are still being developed by practitioners. For example, there are temperature sensors, calculator screens, computer monitors, or LCD, which we can see in the picture here. Next, as you might not know, the phases that occur in liquid crystal depend on the temperature. The types of liquid crystal phases are divided into three, which we can see on the picture here. They are nematic phase, which is the phase in simplest liquid crystal and form for the first time when cooled. Smectic phase, which is the phase when the shape of smectic orientation can change into smectic A and smectic C. And the cholesteric phase, which is the phase when liquid crystal will freeze to form crystalline solids at low temperatures. The last one is the working principle of liquid crystal. The sensitivity of liquid crystal can be seen on the surface in contact, or there is an electric field and magnetic field. The working principle of liquid crystal can be seen at the picture here. Without an electric field, light will pass through the liquid crystal and filter. Meanwhile, if an electric field is applied to the part to be displayed, the orientation of the molecules will be amplified in that area and cause differences in light polarization. The next topic is brought to you by my friend Julian.
Thanks, Aya. Hi everyone, I'm Julian. In this opportunity, I would like to tell you about polymers. My section is divided into two parts. The first one is about natural polymers and the second one is about synthetic polymers. Before we jump into that part, we must know what is exactly polymers is. So, polymers is contain two Latin words, poly and meros. Poly means many and meros means unit. So what polymers is a larger molecule that consists of a chain or network of many repeating units that called monomers. The process from monomers to polymers is called polymerization, as you can see in my screen. In general, polymers is divided into two parts, natural and synthetic. Natural consists of cellulose and natural rubbers, and the synthetic consists of polymer addition and polymer condensation. The first one is about natural polymers. There is a cellulose. So, cellulose is a polysaccharide that is often found in plant cell wall. In the wood, cellulose is contain about 50%, and in the cotton almost contain 90% of cellulose. Cellulose from wood fibers is contain many impurities that can be purified by dissolving it in a mixture of NaOH and CS2. The product of the cellulose of wood is there's a fabric named rayon and paper named cellophane paper. In other hand, the cellulose from cotton can be formed to yarn, the head of the cotton bud, and cotton itself. Second is about natural rubbers. Natural rubbers is composed of cis 1,4 isopropane with an average chain length of 5,000 isopropane units. The problem is natural rubbers is arranged in an orderly manner, so the tacticality is the problem of the natural rubbers. So in 1839, Charles Goodyear is invented the method of vulcanizing natural rubbers with sulfur so that natural rubbers can be changed its elasticity. The product of the natural rubbers is there is a tire, the belt, and pipe. The second is synthetic. About synthetic polymers, there is polymers addition. Polymers addition is additional polymers is a polymer that occurs through an addition reaction. This is reaction that involves compounds containing a double bond, then converted into a single bond. This is a 5 of polymer addition. The first one is PVC. The second is polyethylene. The third is polypropane. The fourth is polytetrafluoroethylene, and the fifth is polymethyl methacrylate. The product of the polymer addition is from PVC is there is a pipe. From polyethylene there is also a pipe. Polypropylene there is a plastic chair. Polytetrafluoroethylene there is pen, and polymethyl methacrylate there is what is called contact lens. Last but not least, there is a polymer condensation. What is polymer condensation? Polymer condensation is a condensation polymers that form through condensation reaction. This reaction involves the formation of unsaturated compounds from saturated compounds. The product of the synthetic problems is bakelite and nylon. So that is from me. I will give it the next materials to Bayu that will explain to you about ceramics and thin film. So Bayu, let's go.
Hello everyone, my name is Yusuf Bayu. I'm from Material and Metallurgic Engineering. Here, I'm going to tell you about my topic. My topic here is ceramic and thin film. For the first one, ceramic. The ceramic were originally derived from the Greek keramikos, which means a form of clay that has undergone a combustion process. Ceramics are alloy of metal and non-metal. Ceramics can be both traditional ceramics and industrial ceramics. Initially, ceramics were widely used to make cups and tiles. Currently, ceramics are used as a material for making export disc brakes. And also, ceramic can be used at high temperatures. Ceramics are easily broken, that can be seen in traditional types of ceramics such as glassware, glass, jugs. Ceramics are high temperature resistant. For example, traditional ceramic can withstand temperatures up to 1200 degrees Celsius, and the modern ceramics, such as oxide ceramics, can withstand temperatures up to 2000 degrees Celsius. My topic is about films. A thin film is a layer of material ranging from fraction of a nanometer to several micrometers in thickness. A familiar example is the household mirror, which typically has a metal coating on the back of a sheet of glass to form a reflective interface. The process of silvering was once commonly used to produce mirrors. Advances in film deposition technique during the 20th century have enabled a wide range of technological breakthrough in areas such as both energy generation, for example, thin film solar cell, and for storage is a thin film batteries. A stock of thin film is called a multilayer.